Welcome to the area of a triangle. I will describe the formula for the area of a triangle and justify it. Whether a triangle is a right triangle, that is, it has a 90-degree angle, or it is acute, having all angles less than 90, or if it's an obtuse triangle, having an angle greater than 90. The formula for the area is 1/2 the base times height, and the base is the length of one side perpendicular to an altitude drawn in that triangle, as indicated by the blue and red segments in each triangle. Here, B is the length of the base, and H is the length of the altitude perpendicular to that base. Okay, I'll explain why the formula is 1/2 base times height in each case. For a right triangle, what we really have is half of a rectangle. And a rectangle area is equal to the product of its length and width. The rectangle, which contains two right triangles of interest, has an area equal to base times height, and so our triangle would have area 1/2 of that, or 1/2 base times height. And so for a right triangle, it's fairly easy to see that the formula for its area is 1/2 base times the height, as it is half of a rectangle with area base times height. An acute triangle can be considered as covering two regions made by right triangles. That is, our acute triangle can be thought of as two right triangles placed together so that their heights are coincident. Notice that the heights of each of these triangles will be the height of our acute triangle, and they will each have bases such that the sum of their bases length is equal to the base of our original triangle in length. Each of these triangles will have area given by the area of a right triangle formula. So for our area of one triangle will be 1/2 B1 times H, and the area of the other triangle will have area 1/2 B2 times H. The area of our original acute triangle will be equal to the sum of the areas of these two, and so we would have 1/2 B1 times H plus 1/2 B2 times H, applying the distributive property, and again, the fact that B1 plus B2 equals the length of our original acute triangle, we again arrive at the formula 1/2 base times height, in this case for an acute triangle. Note that this reasoning would apply for an obtuse triangle in the case that our base altitude pair or choice was such that our altitude was inside the triangle. Otherwise, if we consider an obtuse triangle and we have a base height pair such that the altitude is outside of the triangle, we'll think of a large right triangle containing our obtuse triangle with side the same as one side of our obtuse triangle, that is, having two vertices the same. And we'll consider another triangle which would be the region included in that large right triangle and not included by our original obtuse triangle. Each of these will have height H and bases B2 and B1 such that the length of our the base of our original triangle is equal to the difference in the lengths of our two right triangles. As the area of regions add and subtract, we can notice that the area of our obtuse triangle would be equal to the area of the large right triangle minus the area of the smaller right triangle. Since those are given by 1/2 B2H and 1/2 B1H respectively, and the base of our obtuse triangle is equal to B2 minus B1, we can apply the distributive property and arrive at the formula. Once again, that 1/2 base times height gives us the area of our triangle in the obtuse case. So in each of the three different kinds of triangles, the formula is always 1/2 base times height. I hope that